Right, let's have a look at naming some covalent compounds in chemistry. Here we can see a caffeine molecule, a stimulant found in soft drinks, teas, and coffees. It's got carbons, hydrogens, nitrogens, oxygens in its structure, and these are all non-metals, so there's lots of covalent bonds existing here. There's 8 carbons, there's 10 hydrogens, 4 nitrogens, and 2 oxygens. Now, we're not going to learn to name something like caffeine, it's a little too large, but we are going to look at naming more simple covalent compounds. And in order to name covalent compounds, the first thing we have to understand is what's a prefix. So the prefix is what can be added to the start of a word to indicate how many of each atom exists in a molecule. Now, when we named ionic compounds, we only changed the ending of the anion. So just up here in this top corner, if I was to ask you guys to name the ionic compound, this one right here, you would say, okay, well, that's sodium and that's chlorine. So we change the ending of chlorine to chloride, or change the ending to IDE, and it would be called sodium chloride. And you'd be right in saying that. Now, that's because ionic compounds exist in fixed ratios. So what that means is that there's always going to be 1 sodium to 1 chlorine. There's no other way to present this information. Now, in a covalent compound, that's not always the case. So we need to think about the numbers of each atoms in a compound. And the prefixes that we'll be using are 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. And we'll only be giving you covalent compounds that use the first 5 prefixes, and these are the ones you'll need to learn for your exam. So mono, di, tri, tetra, penta. Okay, so let's just pretend this didn't make sense to us for a second, and let's look at maybe another example. So I'll write in CO2. Now CO2 we might recognize, especially if we're familiar with climate change and greenhouse gases. CO2 is called carbon dioxide. And you might notice right here we've got the first time we've maybe seen our prefix. Let me just put an arrow there. So there's our prefix. It's di. And that indicates there's 2 oxygens present. So if you go back to the chemical formula, it's CO2. And that 2 means that there's 2 oxygens present. Now, why is it important that we have that there? Why is this not just called carbon oxide? Well, let me show you something else, another covalent compound. It's CO. This is called carbon monoxide. Now, both of these compounds, CO2 and just CO, exist in the natural world. Yeah, but we can see that the difference is in this one there's 2 oxygens present, and in this one there's only 1 oxygen present. So how can we name these things, CO2 and CO, so that we know when we're talking about carbon dioxide and we know when we're talking about carbon monoxide? Well, you've guessed it, that's where we use the prefix. So here's the prefix for 2, di, and then right here, mono, there's the prefix for 1. And if we know our prefixes, we know that carbon dioxide means there's 2 oxygens present, and if we know carbon monoxide, we know mono means 1, we'll know that there's 1 oxygen present. So let's have a look at our first example now. So here we've got hydrogen and sulfur. Let's write that in. So hydrogen and sulfur. So I think the first thing we should be doing is having a look at what makes up this compound, hydrogen and sulfur, and figuring out, hey, is this actually a covalent? Now, you're right in saying, well, yes, it is, because we're learning how to name covalent compounds, but how else can we think about this? How can we be sure? Well, hydrogen's a gas and sulfur's a non-metal, so they're both non-metals, and when 2 non-metals bond, they usually bond using a covalent bond. So we know that we're right, this is a covalent compound here. How do we name this thing? Well, you can see this little 2 up here. This means that there's 2 hydrogens present. So we need to think about the number of hydrogens present. We need to think about the prefix for 2. So the prefix for 2 is di, and we need to put that at the start of our compound. So di, hydrogen. And now we need to think about sulfur. And there's 1 sulfur. And just before I finish, you might be thinking to yourself, hey, is this going to be sulfur? Is it going to be monosulfur, or is it going to be monosulfide? Well, just like in an ionic compound, we also need to change the ending to IDE to indicate that this isn't a compound. And so this compound is now called dihydrogen monosulfide. Let's move on to second example. So BrF5. So let's think about what Br is. It's bromine, and F is fluorine. So what's this one going to be called? Well, bromine will be mono for 1. So monobromine. And then 5. Oh, gee, what's 5? So 5 is penta. So penta fluoride. And there we go. So it becomes monobromine pentafluoride. So just to go over again what we've done, we've indicated using prefixes the number of each atom. So here's Br, so bromine, and there's 1 bromine. It doesn't need to be written in there. The fact that we've got the chemical symbol there means that there's at least 1. There's 1. And we've got 5 fluorine, so pentafluoride. Now, technically, you can get away when you're naming covalent compounds. With the first one, we can write it like this. We can say it's going to be bromine pentafluoride. Now, why can we do that? Well, it's the same reason we can remove the word mono for the same reason why we can remove the number 1 up here. The fact that I am mentioning it indicates that there is at least 1, or that there is 1 present. If there wasn't 1 bromine present, then we wouldn't have written bromine. So mono or no mono, it means the exact same thing. And in the exam, you'd be given full marks regardless of which one however you wrote this. Let's have a look at the third example. So PH3. So P is phosphorus, and H is hydrogen. So let's name this thing. So how many phosphoruses are there? Well, 1. So monophosphorus. And then how many hydrogens? 3. And so the prefix for 3 is tri, hydride. And again, we can remove the mono at the start of phosphorus. So it can be phosphorus trihydride. And there's our final answer. Let's have a look at another example. All right, CO, excellent. So let's have a look at this one. We've sort of already done this one, so let's speed through it. It's carbon, oxygen. So it could be monocarbon, monoxide. Now you're right in saying, hey, could this just be called carbon oxide? Yeah, it could be called carbon oxide. Generally though, this one is called carbon monoxide, so they actually leave the prefix mono at the beginning of the oxygen here. So I got to be honest, I would accept all 3 of these answers in the exam. Okay, we don't technically need to mention that it's mono. The fact that you've written in oxygen, oxide, indicates that there's at least 1 present. But we would generally call this carbon monoxide, and that's really got to do with how people, or what word people use in day-to-day life. People call it carbon monoxide. Alrighty, so this is worth noting. Some names are just straight weird. Let's have a look at a couple of examples. This one here, if you don't know what this one is, well, you're in big trouble. H2O is water, and we know that water is what you would call it. You probably would not call it hydrogen monoxide or even dihydrogen monoxide. But water is what we call a common name, and that's just the way it goes. It does have an official name, and you could call water technically hydrogen monoxide or even dihydrogen monoxide, and you would be correct in saying that. NH3 is another one, 2 nonmetals, nitrogen and hydrogen. It's called ammonia. Why is it called ammonia? Well, this one really comes down to marketing. There are lots of companies out there that sell ammonia as a product. You can go down to Woolies or Coles and you can buy ammonia, no worries at all. It's like a cleaning product. That's just what it's called commercially. Its official name would be nitrogen trihydride. Okay, here's another example, H2O2, hydrogen peroxide. This one's a little bit different, but yeah, this one, there's got some other sort of naming rules that kick in here, but its official name would also be hydrogen dioxide or even dihydrogen dioxide. So I guess a couple of things to note here. You can have what we call common names or commercial names, marketing names, and you can also have sort of some weird things going on here where there's a little bit more chemistry behind it. At the end of the day, though, all three of these examples, they have their official name and then also their common name as well. All right, your turn. Pause the video, have a go at these ones. Alrighty, so let's see how you went. So what have we got? We got nitrogen, fluoride. We've got diphosphorus, pentaoxide. We've got nitrogen oxide, or I mean all of these, there are variations to all of these, but this one's also nitrogen monoxide. And then we've got dinitrogen oxide, or even dinitrogen monoxide. Great, how'd you go? Alrighty, let's try them mixed up now. Here we've got a few different examples of both ionic and covalent compounds, and you need to figure out, hey, which one's which. So there's a little bit of a process I've identified over here to help you out. First of all, recognize what atoms are involved. Then, is it ionic or covalent compound? Are there any radicals? Or, we'd probably know this now as polyatomic ions. Are any of them used? And we need to think about how we name polyatomic ions. And then what do the prefixes and suffixes tell us about the type and number of each atom? And what do we need to do? Pause the video, see how you go. All right, let's have a go at some of these then. This first one, ammonia, chloride. It's ionic too. Probably should have mentioned that first. This one down here, covalent. This one here is ionic. Ionic, covalent, and covalent. All right, let's go back and name them. So phosphorus, trichloride, silver, fluoride, copper oxide, dinitrogen pentaoxide, and this last one, this one's a good one because it's written in words and we first of all need to convert it to chemical formula. So it's going to be C. Oh, okay, so C, there must be one. They haven't put di in front of it as the prefix, so there's got to be at least one, or one only, and then it's got tetrachloride, so it's going to be Cl. Now what does tetra mean? Well, mono's 1, di's 2, tri's 3, tetra's 4. And there we go, so we're working backwards there, and that's the final answer. How'd you go?